A little tutorial here to help illustrate retrograde motion. Going back to our thinking about a heliocentric view of the solar system versus a geocentric view of the solar system, this is one of the key pieces of evidence that both of those models had to reconcile with. In a heliocentric model, we could understand retrograde motion fairly simply because that is either you're an interior planet and you're lapping an exterior planet or a superior planet, and as you're pulling ahead you're going to see it appear to go backwards, or you're the superior planet and you're being lapped by an interior or inferior planet. So retrograde motion is a natural consequence of the relative motion because everything is moving around the sun. In the geocentric model from Ptolemy, that also had to explain retrograde motion, when it would happen, how big the amplitude of retrograde motion would be, and that was done with epicycles. So a planet did not move on a single circular path, but it would move in a circle set upon a circle. And if you wanted even higher precision, you would put a circle upon a circle upon a circle. So you'd have, in principle, an endless series of epicycles to explain not just retrograde motion, but to give you predictions for where the planets would appear in the sky any time of the year. All right. One of the most difficult parts of constructing an accurate model for planetary motions is that planets seem to wander among the stars. Hence the name, planet is wandering star. During their normal or prograde motion, planets appear to move from west to east over many consecutive nights as seen against the background stars. However, they occasionally and predictably appear to reverse direction and move east to west over consecutive nights as seen against the background stars. This backward motion is called retrograde motion. And we have some data here for a hypothetical planet and the sort of the time scale of its motion. This isn't too dissimilar from what we would have for Mars in its retrograde motion. So given the data in Table 1, plot the motion of the mystery planet on the graph provided in Figure 1. Record dates next to each observation, each position you plot. Then we're going to draw a smooth line or curve using your data points to illustrate the path of the planet through the sky. So I went ahead and plotted the points and didn't use a ruler or anything all that terribly precise. So when you draw this out on your own, you very well might have done a better job than I. But with some experience, I know that this does have the loop-de-loop of retrograde motion in it, and that's what we're shooting for. So we're starting on May 1st, May 15th, June 1st, June 15th, July 1st, July 15th, and then August 1st, August 15th. So whoop, there's our little loop-de-loop. And then we have some questions to answer about this. And notice this is over a time scale of months. All right, on what date does a mystery planet, on what date was a mystery planet located farthest to the west? What was the azimuth value of the planet on this date? All right, so furthest west is closest to 270, and that is May 1st. And the azimuth on May 1st was 240 degrees. On what date was a mystery planet located farthest to the east? What was the azimuth value of the planet on this date? So furthest to the east was at 120 degrees, and that was on August 15th. Describe how the mystery planet moved east or west as compared to the background stars during the time between the dates identified in questions 2 and questions 3. So it mostly is moving from west to east, except there's a period of time when it's doing our little loop-de-loop. So it's mostly west to east with a loop. During which dates does the mystery planet appear to move with normal prograde motion as compared to background stars? In which direction, east to west or west to east, does the planet appear to be moving relative to the background stars during this time? So west to east is to smaller azimuth. So we've got a period from May 1st to June 15th. Then it moves to the west, and then it starts moving back to the east. So from July 15th to August 15th. Those are the times when it is moving west to east. During which dates does the mystery planet appear to move with backward, retrograde motion as compared to the background stars? In what direction, east to west or west to east, does the planet appear to be moving relative to the background stars during this time? So the retrograde period is going to be in here. June 15th through July 15th. So basically a month. It is moving to larger azimuth, so it's moving further west. All right, important question here. If a planet were moving with retrograde motion, how would the planet appear to move across the sky in a single night? Where would it rise? Where would it set? Okay, so how far would it move across the sky in a single night? Well, we're seeing it move degrees across weeks, right? So it's moving like a degree per day or so. So it's not moving far in one night compared to the background stars. And this retrograde motion is not going to overcome the daily motion due to the Earth rotating on its axis. So it's still going to rise in the east and set in the west. Okay. Putting aside the fact that it's going to be like north or south, due east and due west, depending upon what season you're in, unless you're precisely on the equinox. So the general pattern of daily motion of the sky still holds. So it's still going to rise in the east, it's still going to set in the west. All right, let's think about what our student is saying. Suppose your instructor says that Mars is moving with retrograde motion tonight. Oh no, Mars is in retrograde and will rise at midnight. Consider the following student statement. Since Mars is moving with retrograde motion, that means that during the night it will be moving from west to east rather than east to west. So at midnight it will rise in the west and move across the sky and then later set in the east. Okay, so everything was great in the first sentence, and then that last sentence, the second sentence, is off the mark. So the retrograde motion on a night-to-night basis, we're talking about moving over a small fraction of the sky. It's not overcoming daily motion. It's nowhere close to the amplitude of daily motion, where the entire celestial sphere is rotating 15 degrees an hour. Okay? These are small changes in the position of stars, of a wandering star rather, a planet, relative to the background stars on a night-to-night basis. So, first sentence is great. Second sentence is a misunderstanding of what retrograde motion for the planets means.